All right, welcome back, boys and girls. What we are going to be talking about right now is going to be Unit 7 CRT preparation. This is Part 2. So we already covered Part 1. And again, what was covered in Part 1 is how to create z-scores. So a quick review of that. We know that z is equal to x minus mu divided by sigma. So again, that's the value minus the average divided by the standard deviation. We also learned that x is equal to z sigma plus mu. So the z-score times the standard deviation plus the average. All right. So what we are going to be talking about in this lesson is kind of more focused on what do we do with this information. And so what we are going to be learning is area under a normal distribution curve. So assuming all of this information is quote unquote normal, that means the average bumps up in the middle and everything trails away from it. This is going to be that information. Okay, so there's three main pieces of information, as you can kind of tell by all of these problems, that we have these three key areas, okay, of an x value, a z-score, and an area. And we are going to transition between these things. All right, so what an x value is what the context, what the story is talking about. So it's hard to kind of pin down what a actual definition of that is, but it's what I say is it's like the percentage that somebody receives on a test. It's the cheese on a pizza, miles on a tire. Again, whatever the story is talking about the question itself. Okay, second is the number of standard deviations value is from the average. So we talked about that in the last lesson. So how far is this x away from mu? Okay, how far is it in terms of standard deviations? Is it one standard deviation away, 1.5 standard deviations away? So it's not actual numbers, but number of standard deviations. Last but not least is the area. Area is a probability or a percentage, and we'll see some examples of those. Like, so for instance, what percentage of the population? They want to know what is the area. Down here is percentage. What percentage of the population? 36% of the population. All right, so that's that type of information they are giving you or asking for areas. Okay, so we're going to run through these 5 examples here, and we are going to see how to break these down. All right, so the first piece of information that's pretty important is to identify what the heck they are giving you and what do you need to answer from it. So here they give us a z-score of 1.76. So if this is the average, a positive z-score will be over here somewhere. And so they gave us a z-score of 1.76. All right, I'll be stealing. And so notice that that is the z-score. So that's in line with the z-score. So the question is, what the heck is the area of this? What is the area? And more specifically, area to the left. Well, that's kind of fortuitous for us because when we look at an area on the z-table, they always give you area to the left. Okay, if we wanted area to the right, then we would have to take 1 minus this unwanted area. However, we want this area, and that's exactly what we need. So we have a z-score of 1.76, and we need to look that up on a z-table. So I have one ready to go right here. So we have a z-score of 1.76. So again, this is the z-table. I look at 1.7, which is this line right here. And I take a look, so that's 1.76. So that intersects at 9608, and that is again the area to the left. Area to the left. So that's exactly what we want. What did I say that was again? 9608. 9608. And there you go. That's the area to the left. So 9608 is the answer that we were looking for. And that is the answer. All right, next. What is the area between a z of negative 1.47? So negative 1.47 would be below the average, so a z-squared of negative 1.47, and a positive 0.16. So we have a z-score. Again, I aligned that with the z of negative 1.47. And I also have a z of positive 0.16. Okay. And so we want to know what is the area in between these two things. And so to find the area in between these two things, I'm going to take the area to the left of this 16 minus the area of that negative 147. So it's the big minus the small. Okay, so first stop is what the heck is the areas of these things? So I need to know the area of 0.16. So I go ahead and look that up on my z table. So 0.16. So positive 0.1. 6 would be same line. 0.16 is 5636. So this is 0.5636. All right. Now the area of negative 1.47. Oops, that's supposed to be subscript. Okay, area of negative 1.47, again to the z table. So here we go, negative 1.4, negative 1.4, 7, okay, to the 7, gets us to 0.708. All right, so as I was alluding to get the final answer of this, what is the area in between these two things? The area would be equal to the big minus the small in terms of areas. Let me make these just a little bit smaller here. Writing is too big. Right. So it's the big minus the small. So here we go. I'll go menu 1. Huzzah. And so this is going to be equal to 0.4928. And that is the answer to our question here. 4928. So that's the area in between the two things. Again, what you do is you take the big area minus the small area. Okay. Population has an average of 12. I'm just going to jot this down. So it has an average of 12. Standard deviation of 3. What percentage of the population is below 10? That's at X. All right. So if the average is 12, that would be this middle line right here. And we're talking about a value of 10. 10 would be below 12, obviously, somewhere down here. And so this has a X value of 10. And they want to know what percentage, what is the area below 10? So the question is asking, what the heck is the area below 10? What is this area over here? Okay, what is the area below 10? All right, so to get this area, so the question is asking, what is this area right here? We first need to turn this into a z-score, and then from a z-score, we can turn it into the area. So the first stop, as I mentioned, is the z-score. Again, this is going to be this equation right up here. So I'll write as best as I can. The z-score of 10 is equal to x minus mu divided by sigma. And so in this situation, that is going to be x minus mu. I'm going to write this actually vertically. My bad. They don't like me do it this way. Right. So this is x minus mu. Sorry, let me finish this. X minus mu divided by sigma. So x minus mu divided by sigma, negative 0.67, because the z-table is only able to handle decimals of 2 decimal places. So negative 0.67 is the z-score. So let me kind of jot this down. So the z-score of this dude right here is negative 0.67. So all that's left is to look that up as an area. So negative 0.6, negative 0.67, okay, 7 points to this column right here. 0.67, 2514, and I think that should be the answer to our question. And so what is the area to the left? What is the percentage of the population below 10? It's 25.14. Leave it as a decimal. This is going to be 0.2514 as the answer. That's the area to the left. Okay, getting a little bit more complicated. So here we have an average of 52. Have an average of 52, standard deviation of 17. What is the probability that it's between 38 and 61? Between 38 and 61. Okay, so what this problem is asking us to figure out is the idea that shade this in, so we're looking for the area between. All right, so what it's doing is it's giving us this problem right here, how to find the area between. So again, we find the big area and subtract the small area, okay? But it's also kind of running with this problem as well, where they don't give you z-scores to begin with, but it's not that big of a deal, so it's kind of a combination of these two problems right here. All right, so the first thing that we do is we find the z-score of each of these things. So I'll find the z-score of 38, for instance. So the z-score of 38 is equal to, and I'm just going to assume that you know how to find these things. What I'm doing is I'm running with this equation right here, x minus mu divided by sigma. So of that 38, so x minus mu divided by sigma. All right, and so we have a z-score of negative 0.82. All right. And then, so what I'm going to do is I am going to do the same thing with 61. And so that is going to be x minus mu divided by sigma, 0.53. Okay. From here, what we do is we find the areas of these things. So negative 0.82, negative 0.8, okay, is 2061, 2061. And the 61, which is 053, 053. I'm sorry, I'm distracting myself. So 053, so positive 0.5, 3 is at 7019, 7019. Oops. 7019. And then the area in between the two, the area itself is equal to the big minus the small. And that is equal to 0.4958. Ooh, almost similar to that answer right there. 4958. That is that idea. Okay, last but not least, and this one is probably the trickiest one. Okay, so a population has an average of 120. Standard deviation of 15. And it says that 36% of the population is below the average. This 36% is an area. So if 36% is below this value, okay, it's obviously over here. But the most important thing is to recognize that, again, the information that they gave you is not an X, but rather an area. They just gave you an area. And the question is, what is the value? Okay, what is that value? So what is the X given an area of 36%? So what we have to do is we have to work backwards, turning this into a Z and then into an X. Let me, again, put some highlighter on here. You know how I love to shade my pictures. So this is the 36% itself. What is this X value that creates that? To the Z table. What we're looking for is a Z-score that produces an area to the left of 36%. Okay, so in this situation, what we're looking for is where is there 36% on this picture somewhere? Okay, where is 36%? And so what we are doing is we're looking for 36%, so 0.36, so we're getting bigger. Okay, here we go. 36% would fall in between those two numbers right there. Okay, that's where 36% is. So which one do we take? Well, we take the one that is closer. So looking at this one, for instance, okay, how far is that away from 36%? Well, that is 0.0032 away from 36% straight up. And then how close is that to 36%? Well, that one is 0.0006 underneath 36%. All right, so we see that this one right here is much closer. So this is the Z-score that we are going to take. So the Z-score that we are using in this situation is that guy right there, which happens to be at 0.36. 0.36. That is our Z-score, and that's how we kind of reverse engineer going from an area back to a Z. So 0.36. So let me do a little finagling here. Oh, and that is an absolute coincidence. That is, I can't believe that just happened, actually. That the area is the same thing as the Z-score. Don't think that that's going to happen. That's alert CNN. This is mind-blowing right there. Okay. Anyways, so yeah, so we look up the Z-score. Again, don't assume that they're the same number. All right, and then back to the question itself, and that is, what is the X? So X is equal to Z sigma plus mu. All right, so on to the numbers. So that is equal to Z sigma plus mu. Z sigma plus mu. I hate it when my equal signs don't align. There we go. Now I look like a mathematician. All right, so Z sigma plus mu. So that is Z times sigma plus mu. Z sigma plus mu, and that gives us our X value of 125.4. Wait a minute. Haha. I know that I did it wrong. Haha. You know what my big mistake is? How can 125, which is obviously over here, be bigger than the average? And I'm assuming that my z-score was actually a negative. Let's take a look. Haha, negative 0.36. That makes a lot more sense. So let's adjust our work. Sorry. This z-score, one that I fed you, is correct but incorrect. It's negative 0.36. So let's try that again one more time. Negative 0.36 times sigma plus mu makes a lot more sense. I'm sorry about that, kiddos. All right. And again, it's just because I noticed that I had a ridiculous answer. I knew that that answer was incorrect, so I had to go back. Because, again, if the average is 120, for instance, if the average is 120, how could that number right there be 125? That's stupid, all right? So that doesn't make any sense. So that makes, look, this makes a lot more sense. Okay, so that is that. Okay, the questions that are on the assignment are very similar to these things. So take a look at them. This is an actual graded assignment, so this will go into the grade book to help bring up your grades and things like that. So hopefully this video was helpful. Follow along and do your best.